Welcome. You are a remarkably well trained audience. Normally at MIT, students only show up at 5 past the hour, but you're all in your seats and ready to go, which I think is a great testament to the person we're celebrating today and his education. So this is a symposium to honor Professor Merrill's 60 years as a faculty member at MIT. I'm Klaus Jensen. I'm the head of the department, and I wanted to welcome you all. I want to thank the speakers in advance for making the trip here. Several of them have made very long trips to get here. Some have come from the Far East, some from the western part of the hemisphere, or from Europe, and some have made it all the way from California. And so I really, the department really appreciate you doing that. And I wanted to, as a start, just give a short overview of the early years of Professor Merrill. We will hear many lectures today about his accomplishments, his impact on biomedical engineering. And I thought I would just start by saying just a few words about his early years. And the start, he's a local Massachusetts. He entered Harvard in 1941 to study classics, and he's always been a Renaissance man, and decided that science was a lot of fun, and he had a lot of interest in science. And at that time, William McAdams of MIT visited Harvard several days a week to present a course in chemical engineering basics. Several of Professor Merrill's colleagues at that time really thought this was a formidable course. That was probably the nicest word they used about that course. And having learned about graduate chemical engineering at MIT and worked with McAdams, Merrill decided to go to MIT for graduate studies. His first extensive contact with polymers came from his course that Warren K. Lewis had developed in colloids and polymers. And I think for us today, it's pretty difficult to imagine what polymer science was like in those days, but it was still very much in its infancy. And so this was really a pioneering effort to go into polymers, but he liked it very much. And so he decided to do his doctoral thesis in cohesive and adhesive behavior materials, especially polymers. And he did this on the direction of Professor Meissner. And these remarks I have actually abstracted from a tribute that Professor Meissner made to Professor Merrill a number of years ago. After his PhD, he spent 3 years at the Dewey-Almy Chemical Company as a research engineer in rheology and studying flow of various materials. And he then returned in 1950 at MIT as an assistant professor. And around 1960, he turned to study blood flow and rheology. And at the inspiration of, I think, perhaps some of his medical school colleagues. And he discovered that blood viscosity is dependent on a number of factors that were so far unknown. And this turned into biomedical engineering, especially for the younger folks who are probably here, was, I think, a very courageous step, a very pioneering step. It was way outside the sort of general field of the discipline, and there were, I'm sure, lengthy discussions at promotion time on whether or not this really ought to be in chemical engineering or not. And of course, nowadays, it is one of the really very healthy and big and central portions of chemical engineering. And I think much to the credit of Professor Merrill's first steps in doing this. He got tenure in 1962 and actually started teaching a course in chemical engineering in medicine in 1963, which is probably the first chemical engineering course in the area of biomedical engineering, and really also emphasized the connection to the medical school, which of course is a key to advance the field. Over his long career, 60-year career, he's been a pioneer in several different fields of bioengineering. In the 1950s and 60s, he was the leading scientist in blood rheology. In the 70s, 60s, and 70s, he was a pioneer in the development of artificial kidney and the hemodialysis membranes. And then in the 80s, he began to pioneer protein polymer interactions under stagnant and flow conditions. We owe all the people that use hydrogel today owe a great deal to Professor Merrill's initial work on hydrogels. And of course, there's also his work on heparization of polymer surfaces in terms of making them biocompatible. And he proposed, along with Ed Saltzman from MGH, the use of polyethylene oxide as a biocompatible material. And of course, this is now a well-used material. And in the 90s, along with Dr. Harris of Harvard, he developed and patented a new type of cross-linked high-density polyethylene that has become the main material for total hip replacements. And I might mention to everyone, that this patent, or these patents, or series of patents that came off of that, has really also been a foundation for this department to continue to develop its excellence. Our ability in the last several years, even in spite of the financial crisis, to attract and help young people grow and bring in really first-class faculty has greatly been benefited by Professor Merrill's contributions. So this is just the announcement of this breakthrough in hip replacement that came out of this work. The locals can see that this is a shot from Channel 5. He has had many PhD students, 57 and 62 masters and 9 postdocs, and I'm glad to see so many of his descendants here. You can't read the names, but you can see that this is a very healthy, well-shaped tree, what you would expect from a New Englander. This is what they look like outside. I might also say that just like big, healthy oak trees in New England, it spreads other oaks around it. And so by Nicholas Pappas's most recent counting, there's about 3,000 scientists, and one way or another can find some ways are associated with him either directly or through his academic descendants. And many of these have made outstanding contributions to the field. They're members of the National Academy of Science, National Academy of Engineering, the Institute of Medicine, and the Royal Society. And I'm glad to say that several of those are here today. In addition to Ed Merrill himself, when the AIC listed the chemical engineers of the modern era, it included 8 of his academic descendants, the highest number of anyone in that list. And most recently, and some of you may have seen that in the picture of, that I showed you, he received the Paul Galetti Award, the highest honor that the American Institute of Medicine and Biomedical Engineering gives. Also remarkable that 3 of his students have won the same award. So with that as an introduction, I want to go back and turn it over to the speakers who will be able to provide a lot more input into Professor Merrill's achievements. We'll start with Professor Langer. Then, as you can see, we kind of switch back and forth between locals and descendants on the outside. So go to Professor Hoffman from University of Washington, David Terrell from Caltech, and then return back to Bob Cohen from MIT. Lunch is going to be upstairs, and to get upstairs at the end, we'll just go out here, and there's a staircase right out here. We'll take you right upstairs to the room in which the lunch will be served. And then we'll have a program in the afternoon as well. And Nicholas Pappas, a long-time big supporter and really big help to it, Professor Merrill, will finish off the program. And so thank you very much for coming, and I very much look forward to listening to the talks.